Hello friends, this is Samsung microwave convection which is working but not heating. Alright, here's the beep. Okay, let me put some water here. This is it's working but it will not heat. There you go. Let us check. Okay, so see the water, it's not heated, so it's very cold. So let us try to troubleshoot here. Before you operate microwave oven, you should be very careful. Never ever touch this portion of the oven without discharging the capacitor here, because this is a very high voltage section, so you might get very high shock of almost 4000 volts. So be very careful about it. So first, before I touch this oven, make sure that you discharge this. Just take a player or something which is having an insulation here, and hold it and touch these two terminals here, right? Hold it for a few seconds so that it can completely get discharged. Alright, so now it's discharged. So basically the problem we have to figure it out is from this section, because if your oven is working fine, then all of these circuits and the fuses here, everything seems to be working fine, because the oven itself is working fine. The problem is it is not heating, right? If you have a heating issue, then most probably 90% of the cases the problem would be either with your transformer, with the fuse right here, the high voltage fuse. All right, and then you have this high voltage diode, I believe, here, and then the capacitor. All right, so these are the and also the magnetron, right? So these are 3-4 parts where you have to check to make sure that all of these are working fine. So first, as we have discharged it, so let us test it one by one. All right, and this is a very rare issue which I have found, so I talked about it. So I have a multimeter here. Let me first put it in the continuity or buzzer mode, what you call it here. Right, there you go. So first thing first, we'll check for the transformer, right? So basically these are this section right here, what you see. So these are the main supply which goes to the transformer, the 230 default voltage which goes to the transformer here. It converts to 2000 volts, and again it will be sent to the capacitor here, which further boosts the voltage to 4000, and this high voltage wire that goes as an input to your magnetron, which takes about 4000 volts, and then that starts working and heats your food. So basically this is how the flow works. So right in this case the oven is working fine, so we have to troubleshoot for these issues why it is not heating. So right from here I'll remove these wires here. All right, before you do these, make sure that you take a picture. So we're going to test the primary winding here for the transformer. So you have basically 3 windings in this transformer: the primary winding, the secondary winding, and then the high voltage winding right here. Right, so this is also a secondary winding, but a very high voltage winding, which is about which boosts the voltage to 2000 volts. So this is basically step up transformer, which takes an input of 230 volts, further boosts it to 2000 volts, and then sends it to the capacitor, which further boosts it to 2000 to 4000, and then it sends it to the magnetron here. All right, so let us test. So I've put in the multimeter in a buzzer mode right here. If you see, this is the buzzer mode. Right. Right. All right. So we are going to test for the continuity here. It should beep. All right, and you get around 3 ohms here, which is good. So this means it is a closed circuit. All right, and also I'll test for any short here, body. All right, so this is not beeping. Other terminal as well. So this is also not beeping. So for these 2 terminals, so the primary winding looks good. All right, then we'll talk about the secondary winding right here. We're going to test the same way. We have these 2 sockets here. We're going to test. This should give somewhere around roughly about 1 ohms of resistance. There you go. You got the 1 ohms of resistance, and this is also a closed circuit. All right, so our secondary secondary winding is also working fine. So far the transformer looks good. Then comes your high voltage winding. All right, so we are going to test the high voltage winding here. Okay, so this is the high voltage. So you have to put in your one lead here, and the other one you have to test it for the ground. All right, and it should reach somewhere around 200. There you go. So the resistance, if you see here, this is about somewhere about roughly about 200. All right, so you have to basically touch right here. I can zoom it a bit. You see, this is the first end of the high tension winding, high voltage winding. This is the first end. This is the second end. All right, so this is the second piece. So basically this is working fine. So you cannot test it. I'm not able to test it because there will be some varnish or something. So they will be coating on this, which will you'll not be able to test it. So the easiest part is you have to test for the you have a ground screw here, right here. So if you test it, you will see the reading here. So far this looks good. Also, the main culprit would sometimes be your the fuse as well. Alright, this is the fuse. So you can see this has this little fuse inside. Alright, so basically, even if sometimes this goes off, the current, the voltage would not be passing through this. Alright, so it will be stuck here and it will not flow in, right, to this portion, and it will not go to your capacitor, and in turn it will not give enough voltage for your magnetron to hit. So basically, if your high voltage fuse is also blown, then you will have this issue. So in this case, there is a continuity, so the fuse looks good. I can also test for the continuity here. All right, you can hear the beep. So our fuse also looks good. All right. Okay, so now whatever we have tested the primary winding, which looks good. We have tested the secondary winding, which looks good. The high voltage winding, which also looks good, and also the high voltage fuse. This also looks good. So far, everything till here looks good. Now let us troubleshoot further. Now here comes the capacitor, all right, and also the diode here. All right, let me remove the diode. Let me first pull this off. Right, there you go. And the only way to test your capacitor is to do a continuity testing, a buzzer mode testing. Okay, so this should not give you a beep. So this should be open circuit, not a closed circuit, right? So this looks good. The capacitor looks good. There is no beep. And I'll also test for the body short. Okay, no beep so far. I'll test for the other terminal as well. No beep so far. All right. So it doesn't give any beep. So this means the capacitor is working fine. All right. Now we are going to test our diode here. So basically, all you have to do is you can only check for a continuity here. So this should not be a closed circuit. This should be an open circuit. So both the terminals looks good. All right. So the diode itself looks good. So this means that the diode is working fine. So far, our transformer is working fine. We have tested our capacitor, which looks good. The diode looks good. Your voltage fuse looks good. All right, and then the last part which has to be tested would be your magnetron. All right, and for the magnetron, the only test what you can do is a continuity test. You have to check for both these probes. There has to be continuity. You see there, the buzzer is beeping, so that means that this is a closed circuit. I'll interchange the probes. Yeah, this is a closed circuit, and also they should not be short. All right, no reading. This looks good. Even this looks good. Let us check the magnetron itself. Let us open the magnetron and see if it is broken. or any physical visible damages, right, which can be seen, maybe a broken magnet or something like that. Okay, so we'll open the magnetron and see. Right, let me open. So we have these two screws here which you have to remove. You have to be little careful. Just tilt it like this, it will come apart, and then just pull it. Okay, so we have removed the magnetron here. We are looking for any physical damages. I don't see any physical damage here. The magnet looks intact, and also there is no sound. There is a filament right inside this. The tube, if you see here, yeah, this is actually closed circuit. The tube and the filament here, right? So we test for the continuity, the closed circuit of this filament, just to make sure that the magnetron is working fine. And the other thing is we check for the physical damages. I don't see any physical damage, neither I hear any sound, right? And also let us check for the continuity here. This looks good, no problem. There is no body short. For the other terminal as well, I don't see any body short. There is a closed circuit. This looks good. So I will be changing this magnetron to see if everything's if this oven starts heating, because I don't have any blown fuse. So, and also the capacitor and the diode looks good. So let me bring a magnetron. Alright, so this is the new magnetron which I've bought. This is Gallon's company. Okay, so we're going to connect this and see if our oven starts heating. Alright, let's connect it. Okay, so I'm going to fix the screws here. Okay, fixing these two screws here for the heat sensor, the temperature sensor basically. Okay, so we're going to connect the wires here, magnetron right here, and then black goes here, and this is input supply. This one goes here. This is an input supply. Okay, and then your diode goes to one section of your capacitor, and then your secondary winding is here, and then your high voltage connection will go to the second part of your capacitor right here. Okay, so this is how it is. Make sure that you take a clear picture before you unplug any wires, because if you connect it differently, that might blow off your capacitor or your transformer or even your motherboard. So make sure that you take a clear picture before you disconnect any wires, and then go for it. Let us turn it on and see if it is working. You hear the beep? Let me grab a bowl of water, put it inside. Alright, let us do a test for 30 seconds. There you go. Looks like it's working. Alright, let us see. Alright, I'm not sure if you, okay, I think you can see the fumes here in the water. Right, this looks pretty hot. Yeah, you can see the fumes coming up. So that worked. So basically you had a faulty magnetron. Let me switch this off first. So the problem was with the magnetron itself. The old magnetron was testing fine but not working. This is the very rare issue which you find where the magnetron would test okay. Before replacing, make sure that the other section you test it thoroughly before you replace the magnetron, just to make sure that the problem is with the magnetron itself. Alright, I hope this video was very helpful. Thanks for watching, and please subscribe to my channel.